first question of exercise 2.2. So it says if set A is equal to 1, 2, 3, 4, and set B is equal to 2, 3, 5, 6, then we need to find A intersection B and also B intersection A, and we should note if they're equal or not. So we have A is equal to 1, 2, 3, and 4. So the meaning of intersection is we need to write the common observations or common elements of which are common in both of the sets. So we would get A intersection B, which are all common. We have 1, we have 2, and we have 3. And this is A intersection B. If we take B intersection A, then we would also have same here also 1, 2, and 3. So we found A intersection B and B intersection A, and are they equal? Yes, A intersection B and B intersection A are equal because the definition of equal sets defines that cardinality of the both sets should be same, which means the number of elements in the set should be same, and also the elements in the both of the sets should be same. Here we have cardinality, that means number of elements. We have 3 in both of them. We have 3 elements in A intersection B and 3 elements in B intersection A, and also we have elements 1, 2, 3 in A intersection B and also 1, 2, 3 in B intersection A. So they are equal. A intersection B and sets A intersection B. Sets A intersection B and B intersection A are equal. We have the question 2 of exercise 2.2. It says if A is equal to 0 to 4, we need to find A intersection null set and A intersection A. And what did we notice from the results? So we have A is equal to 0 to 4, and we need to find A intersection null set. Intersection is we need to find the equal elements, the common elements in the both of the sets. Here, since there are no elements in a null set, we would get a null set as the answer. And when we find A intersection A, if we check A, then an intersection with itself, we would get the same elements because the common elements in both of the sets are 0, 2, and 4. Since we found A intersection, A intersection 5 and A intersection A, what did we notice from the result? We noticed that whenever we find intersection with any set with null set, we would always get an empty set as the answer. When we find intersection of a null set with any set in the world, we would always get a null set as the result. And when we intersect a set with itself, when we find intersection a set with itself, we would get the answer as the set only. So we can write the result as A intersection phi is equal to phi, and any set intersection with itself, we would get the same set as the answer. The third question of exercise 2.2, which says if A is equal to 2, 4, 6, 8, 10, and B is equal to 3, 6, 9, 12, 15, and we need to find A minus B and B minus A. So to find A minus B, first let's write the given information 2, 4, 6, 8, and 10. Next B we have 3, 6, 9, 12, and 15. To find A minus B, we have a small trick here, which is first we would write simply like A minus B minus B set 3, 6, 9, 12, and 15. And now we cancel out the common elements in the both ones. So we have 6 only common here. We don't have 2 common, we don't have 4. We have 6, we don't have 8, we don't have 10. So after cancelling the common elements, we would only write the remaining elements in the first set here. So A minus will be 2, 4, 8, and 10. And if we find b minus a, it's like 3, 6, 9, 12, 15 minus 2, 4, 6, 8, and 10. First cancel the common terms in both of them and write the remaining elements in the first one. 3, 9, 12, 15. So a minus b will be 2, 4, 8, and 10, and b minus a would be 3, 9, 12, and 15. Now the fourth question of exercise 2.2, it says if a and b are two sets such that a is subset of b, then what is a union b? Explain by giving an example. So let's take an example. We have, let's take a is equal to 1, 2, and 3. Let's take b is equal to 1, 2, 3, 4, and 5. It satisfies the condition that a is a subset of b. So now they told us to find what is a union b. So union means we have to write all the elements each one time. So we would get 1, 2, 3, 4, and 5, which actually is b. So if A is a subset of B, then A union B will be equal to B. We have the fifth question of exercise 2.2. So it says if let A is equal to x such that x is a natural number, set B x such that x is an even natural number, set C x such that x is an odd natural number, and D is such that x is a prime number. So first let's write the set roster forms of the set builder forms. So set A have natural numbers, so we would get 1, 2, 3, 4, and so on. Next set B we have x is even natural number, so we would have only even numbers here 2, 4, 6, 8, and so on. 2, 4, 6, 8, and so on. Next set C we have odd natural numbers, so we would have 1, 3, 5, 7, and so on. And lastly set D we have x is a prime number, so 2, 3, 5, 7, and so on. So they are asking us to find A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. So first let's find A intersection B. So the common elements in both of the sets are even numbers, because if we see A, it has all natural numbers, and if we see B, it has only even natural numbers. So common terms would be only even natural numbers 2, 4, 6, 8, and so on. Next, A intersection C, similar to the above one, we would have here odd natural numbers 1, 3, 5, 7, and so on. Next, third one, A intersection D, similarly A has all natural numbers and D has only prime numbers. So when we find intersection, that is, if we check the common elements in the both of the sets, we would get all the prime numbers. So 2, 3, 5, and so on. Next we have B intersection C. B has all even numbers and C has all odd numbers. So there wouldn't be any common elements in both of the sets. So it will be a null set here. B intersection C is a null set. Next, B intersection D we have B has all even numbers and D has prime numbers. If we find intersection, we would get even prime numbers, which is only element 2. 2 is the only even prime number. Next, lastly, we have C intersection D. C has all odd numbers and D has all prime numbers. So C intersection D would contain all the elements except 2 in the prime number. So we would get 3, 5, 7, 11, and so on. We have the sixth question of exercise 2.2. So it says if A is equal to, they gave a set of B, they gave set C and set D, and told us to find A minus B, A minus C, A minus D. B minus A, C minus A, D minus A, B minus A, sorry, B minus C, B minus D, and lastly C minus B and D minus B. So to subtract any sets, first we have here A minus B. Let's write the sets here: 3, 6, 9, 12, 15, 18, and 21 minus 4, 8, 12, 16, and 20. To subtract, first we must cancel out the common elements in both of the sets. We have 12 common here, and I believe that's it. Yes, only 12 is common, and we should write the elements only in the first set here. So we would get 3, 6, 9, 15, 18, and 21. Next we have A minus C. First let's write A set: 3, 6, 9, 12, 15, 18, and 21. We have set C here: 2, 4, 6, 8, 10, 12, 14, 10, 12, 14, and 16. So for to cancel, we have here 6 we have common, and 12 we have common. So we have two elements common here, and if we subtract and write the only the first set elements, we would get 3, 9, 15, 18, and 21. Next we have A minus D. Let's write A set here: 3, 6, 9, 12, 15, 18, 21. Element, sorry, set D has 5, 10, 15, and 20. So minus 5, 10, 15, and 20. So in this both sets we have only one element common, that is 15. So if we subtract and write the answer, we would get 3, 6, 9, 12, 18, and 21. Next one we have, next we have B minus A. Set B contains 4, 8, 12, 16, and 20 minus set A contains 3, 6, 9, 12, 15, 18, and 21. If we cancel out the common terms, we have only one term common, which is 12. And if we write the rest of the elements in the first set, we would get 4, 8, 16, and 20. Next one we have, after B minus C, we have C minus A. If we write out the elements, we have 2, 4, 6, 8, 10, 12, 14, 16 minus, in set A we have 3, 6, 9, 12, 15, 18, and 21. The common elements in both of these sets are, we have two common elements, which are 6 and 12. These are the only common elements we have. So if we write the remaining elements in the first set, we would get 2, 4, 8, 10, 14, and 16. And after C minus A, we have D minus A. First write the elements of set D, which are 5, 10, 15, 20, minus we have set A: 3, 6, 9, 12, 15, 18, and 21. The common elements here, only we have only one common element, which is 15. So and if we write the remaining elements, we have 5, 10, and 20. After D minus A, we have B minus C. Set B contains 4, 8, 12, 16, and 20. Set C contains 2, 4, 6, 8, 10, 12, 14, and 16. and the common terms here are we have 4, 8, 12, 4, 8, 12, and 16. We have 4, 8, 12, and 16. So we will get here the remaining elements is only we have only 20. And next one we have after b minus c we have b minus d. First let's write b set 4, 8, 12, 16, and 20. And in set d we have 5, 10, 15, and 20. Here we have only 20 common here. So if we cancel out those elements and write the remaining elements in the first set, we have 4, 8, 12, and 16. Next, after b minus d, we have c minus b. So in set c, we have 2, 4, 6, 8, 10, 12, 14, and 16. And in set b, we have 4, 8, 12, 16, and 20. If we subtract cancel the common elements, we have 4, 8, 12, and 16. 4, 8, 12, and 16. And the remaining elements in set A are, first set are 2, 6, 10, and 14. And last one after C minus B, we have D minus B. Set D is 5, 10, 15, and 20. Subtract B here, we have 4, 8, 12, 16, and 20. If we cancel the common elements, we have only 20 here, which is common. And let's write the answer. We have 5, 10, and 15. So it's the last one, D minus B. So uh, to subtract two sets, first write it set A minus, if we subtract B minus A, we have right set set A minus set B, cancel out the common elements in both of the sets, and write the remaining elements in a set from the first one. If we write A minus B, cancel out the common terms and write the remaining elements from the set A will be the answer. That- That's it. Hope you understood the 6 questions of exercise 2.2. For solutions of other exercises, there are playlists of different exercises of this chapter are given in the description down below. Check out those and subscribe for the solutions of the next exercises. Thank you.